useful screen for us because we can monitor the health of the aircraft by scanning the different systems. Here is the location of the flight controls, basically, the stabilizer trims, the aileron, and the rudder. We also have our oxygen amount here, cabin temperature, cabin altitude, the cabin rate, and the change in pressure. So right now at 27,000 feet, we have 7.9 psi. So if you wonder what kind of pressure is on that window you're looking out, every inch is holding 7.9 pounds of pressure. So it's holding a lot. We also have the APU is not showing because it isn't running. Our APU in this specific flight was inoperative. That's why it is showing in magenta. This is our environmental control systems page. You can see the cabin temperature for the people in the back is 24 degrees Celsius. And we have basically two systems that feed the airplane from the left engine, from the right engine. We'll keep it simple with that. And you can see the output of those systems and the flow of that air and how it enters into the aircraft. So it comes from the engine, it goes through our air conditioning pack, cools that hot engine air down, and into the cockpit, that air is 19 degrees Celsius, and into the cabin it's 2 degrees Celsius because we're trying to keep the cabin nice and cool. And the pressure coming off those engines, you can see, is 69 psi on the left and 67 psi on the right. And again, some basic cabin information down below there. The cabin altitude right now is only at 3,600 feet. And that's all automatically controlled, so it really is kind of a nice feature of the CRJ. We don't have a whole lot of input here. The computer detects our climbs and our descents. Here's another page indicating all the doors on the aircraft. Once again, green is good, red is probably not so good. And here is our flight controls, kind of the same ideology here with the colors. Here's our fuel page, same thing, a nice schematic, fairly basic schematic, but it really helps with troubleshooting. Hydraulic systems, very, very useful pages here. You can see all the systems on each hydraulic system labeled down below, and in this case I believe we were on the ground here, so some of these systems are not being operated at that time, so they are in yellow. And the white is also just informational, showing which systems are on that. The center system is on 2,900 psi. That is an electric pump. Here's the anti-ice. And here's an overheat of the anti-ice system. It shows red. We get an audio warning with that. And you can see all the valves there. Here's the DC electrical. And if you can make sense out of all that spaghetti, good job. Shows all of our DC buses and the voltage running through each bus and where it's coming from. You can see the APU batteries there and so forth on the bottom. And we have utility buses, essential buses, battery buses, bus ties, and so forth. So depending on your switchology and your position to the switches, you can see the results right here on this screen. That again will help you troubleshoot any problems. Our particular aircraft only has one FMS, some do have two, so we'll take a look at our one FMS here. This is kind of the brains, the flight management system. As pilots, we put in all the input for the routing and so forth and performance into this computer, and it talks to the airplane, the navigational systems, and pretty much aligns all the computers to take us from point A to point B. Here you can see, once again, we are direct to Albany in the magenta at flight level 270. The next waypoint is Echo Echo November at 102 degrees and 67 nautical miles, and then off to Manchester. So we can get all kinds of information from this computer. This is only the active legs page, but you can see how useful the information is and how easy it is to get information quickly. The information derived in this FMS is also what displays those needles we talked about earlier on the PFD, such as the white needles, the wind information, and so forth. It's all done through some basic algorithms within the computer here. At the top right-hand side, you can see that it says auto/inhibit. Auto means that the computer automatically, it knows all the frequencies of the VORs and ILSs and all that. So if we program that into the FMS, it automatically tunes all of our radios for us and eliminates that workload as well. Here's a live view in flight on our way to Manchester.
Turn right heading 280 and a step localized runway 31 right on that heading, maintain 4,000.
And here's another page. We have thrust limitations. This is performance information. Here's a progress page. This shows a lot of information here. Sorry about the bad camera here. It shows headwind, crosswind, and other pertinent information that we sometimes have to take a peek at here. You can see wind is 270 degrees true at 105 knots here, and the outside static air temperature is minus 38 degrees Celsius. Radio tuning, we can also tune our radios right through here by punching in the numbers if we want to, and that's a handy feature sometimes if you're kind of busy and you just want to directly dial something in. Again, we have auto and manual tune, and then we're back here to the legs page. Holds at the bottom. If you need to do a hold, you just punch in the fix, and it draws the hold and everything for you. It's really easy, and an autopilot will fly the hold as well, so it allows you to focus on other things. Here we are back to the MFD showing us just cruising along here. We've really cleaned up the screen. You can only see one airplane off the right there. It's 4,200 feet below us and climbing. This here is our text unit, basically. This is what we communicate to back and forth. We call ACARs. Communicate back and forth to the company and so forth, kind of like text messaging. But we can also get all the airport information, the ATIS and clearances via a text format, also weather and so forth, text format through here. So if we're busy on the radios and so forth, we can punch in the information right here through the display, and we can read it while we're still listening to the radios, and it also keeps a copy. So if we forget what it said, we can go back and refer to it.
Jet pipe overheat. Gear bay overheat. Smoke. Bleed air duct. Anti-ice duct. Wing overheat. Config flaps. Config trim. Config spoilers. Config brakes. Config autopilot. Cabin pressure. Door. Nose door. Gear disagree. Brakes. Engine oil. APU. Cell call. Wind shear. Wind shear. Wind shear. Terrain. Terrain. Pull up. Sink rate. Pull up. Terrain. Pull up. Don't sink. Don't sink. Too low. Terrain. Too low. Gear. Too low. Flaps. Too low. Terrain. Flight slope. Bank angle. Bank angle. Minimums. 500. 100. 50. 40. 30. 20. 10. Wind shear. Wind shear. Wind shear. Too low. Terrain. Caution. Terrain. Caution. Terrain. 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 Pull up. Caution. Obstacle. Caution. Obstacle. 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 Pull up.